Hi, it's me again, Sir Hendrik from Hendrik Academy. On my previous video regarding stationary points, I have explained how to find a stationary point on a quadratic function. In this video, I will explain how to find the stationary points on a cubic function. Before I begin this lesson, please click like and subscribe for this video. And afterwards, taking your pen, your pencil, notebook as well, and your ruler, and let's study with me till the end of this video. All right, I will begin with the understanding. Yeah, I will review this concept that if first derivative equals 0 and the second derivative of fx greater than 0, so the coordinate points x comma fx we call as minimum point or minimum turning point. If the first derivative equals 0 and second derivative of fx less than 0, so the coordinate point x comma fx we call as the maximum point or maximum turning point. While if the first derivative equals 0 and also the second derivative equals 0, so the coordinate point x comma fx we call as point of inflection. No minimum turning point and no maximum turning point as well. All right, I will discuss this problem. Find the stationary point, maximum or minimum turning point on the curve y equal x cubed plus 3x squared minus 9x minus 5. And also I will show you how to sketch this graph based on the maximum point and the minimum turning point, and also according to the gradient of this graph. All right. The first step, we have to find the stationary point. Yeah, the stationary point of this functions. And to find the stationary point of these functions, you need to find the first derivative of these functions. And the first derivative of these functions becomes 3x squared plus 6x minus 9. Okay, if 3x squared plus 6x minus 9 equals 0, and if we divided this equation divided by 3, okay, this equation is going to be x squared plus 2x minus 3 equals 0. And through factorizations, we could factorize, through factorization method, we could factorize this equations becomes x minus 1 multiply x plus 3 equals 0. And we found two possibilities to find x, that is x minus 1 equals 0 or x plus 3 equals 0. If x minus 1 equals 0, it means x equal 1. And if x plus 3 equals 0, it means x equal minus 3. So there are two stationary points, x equal 1 and x equal negative 3. Okay, later we will using this stationary point to graphing or to sketch this graph. All right, and afterwards, the next step, we need to find the second derivative. The second derivative equal 6x plus 6, so 2 times 3 is 6, and derivative of 6x equals 6. So second derivative of this function equal 6x plus 6. Look, if x equal 1, because this is the stationary point, if x equal 1, and if we submit 1 into this equations, into this second derivative, this second derivative will become 12, because 6 times 1 plus 6 equals 12, and 12 greater than 0. If greater than 0, it means this functions, this function has minimum point, okay, has minimum point in x equal 1, okay. In x equal 1, this function has minimum point. What is the minimum point? We could find the minimum turning point or the minimum coordinate point when this x, when this number x equal 1 submit into this equation, into these functions, y equal x cubed plus 3x squared minus 9x minus 5. If this x, and this x equal 1, like this, the calculations, and we're going to find y equal negative 10. So it means when x equal 1, y equal negative 10. And we already found the minimum turning point or the minimum coordinate point, 1, negative 10. All right, so how about if x equal negative 3? If x equal negative 3, the second derivative will become like this. Yeah, if we submit this x into this this equation, the second derivative will become 6 times negative 3 plus 6 and equal negative 12. Negative 12 is less than 0. If less than 0, it means when x equal negative 3, this function has maximum point. Okay, now we are going to find the maximum turning point or the maximum point, the maximum coordinate point. How to find the maximum coordinate point? Submit this number, negative 3, into this functions equation. And you could find like this, the calculations, y equal 22. So for maximum turning point or the maximum coordinate point, we already have this point, this coordinate point, negative 3, 22. All right. Afterwards, the next step, we're going to find the gradient. Recall that the coordinate point are negative 3, is a number, and positive 1. Okay, so therefore, I have write down here in this table negative 3 and positive 1. And why negative 4? Negative 4 is the number below of negative 3. And why negative 1? Because negative is a number between negative 3 and 1. And why 2? 2 is a representative number of the number after positive 1. All right. Now we are going to find, we are going to fill every column of dy dx of the first derivative, like this. Okay. If x equal negative 4, the first derivative will become 15. If you submit negative 4 into this x, negative 4, you could find this number, y equal yx or first derivative equal 15. So therefore 15 here. If this number, if you submit negative 3 into these equations, the first derivative would become 0. Okay. If negative 1, the first derivative would become 3 times negative 1 squared plus 6 times negative 1 minus 9 equal negative 12. This one, because 3 minus 6, okay, -3, and -3 minus 9 equal -12. So therefore, -12 here. Okay, if you submit 1 into this equation, yeah, the first derivative would become 0, this number. And if you submit 2 into these equations, yeah, if this x equal 2 and this x equal 2 as well, so this first derivative will become positive 15. Okay, recall that if positive, it means the gradient increasing. Okay, if negative, if 0, it means there is no gradient. Okay, because stationary point, maximum or minimum point. And afterwards, if negative, it means the gradient decreasing. Okay, and 0, it means no gradient. Yeah, and then positive, the gradient increasing as well. All right. If you will sketch, yeah, in this graph, firstly find the turning point, the maximum turning point and minimum turning point, or the maximum coordinate point and the maximum and minimum coordinate point. Recall that maximum coordinate point is -3, 22. Which one? -3, this one. 22, this one. Okay, this is the positions or the locations of -3, 22, and next afterwards, the minimum coordinate point is 1, -10. Just now I already explained on my previous slide, and afterwards we found this minimum coordinate point, 1 and -10 here, the locations in this graph. And next we need to find the intercept between these functions and this axis, y-axis. Yeah, if x0 is 0 and 0, it means the intersect in this point, 0, -5. All right. Based on this information, this gradient, that before this maximum turning point, the gradient is increasing. So like this, increase until this maximum turning point, and afterwards, after this maximum turning point will be decrease. Okay, will be decreased through this intersect point until this minimum turning point, and after minimum turning point, this graph will be decreased like this. Okay, yeah. So that is the method to sketch, yeah, how to sketch the graph, this cubic graph, according when you already find the gradient, maximum point, and minimum point as well. And I'm going to show you the real graph of these functions like this. Okay, recall that when x equal -4, the gradient is increased, and this is the maximum point. And when x equal -1, the gradient decrease. Okay, and this is the minimum turning point. And when x equals 2, the gradient is increase like this. Okay, so students, if you have any questions, or maybe some of you not understand yet regarding my explanation, you could send me your message through this email, hendrik.academy21@gmail.com. Thank you for your watching, and thank you already study with me till the end of this video. See you